little bit, Mom.
I'm going to just send out an invitation because I don't see Gideon. Oh, where is he on here? No. So if you, yesterday he kind of waited for the email. So as long as we're a little slow getting started here, it's not going to take that long to present arithmetic sequences. Do any of you know what an arithmetic sequence is?
Isn't that the one that's like either you multiply to get the next thing or it's like addition? Maybe it's both.
It's addition. You are
Okay.
right.
We've done them before. That's all I know.
Yep, we have. Okay. Well, I've sent him a thing there, so hopefully he'll be joining us soon. All right, arithmetic sequences in series. It is a sequence where you have to add to get the next term in the sequence. So the things that we are going to be needing to find here is the first term, which is a sub 1, d, which is called the common difference. Sometimes we have to find a sub n, which is the nth term. And sometimes we just have to find the first few terms. So the thing that is going to be kind of hard about this one and geometric sequences, there are some formulas that you're going to need to know.
I like formulas.
Yeah, I do too, because then you know what you need to do. Okay, a sequence in which each term after the first is found by adding the same number to the preceding term is an arithmetic sequence. And a sequence is arithmetic if there exists a number d called the common difference such that a sub n plus 1, which we know that means the next term, is equal to the current term plus d for any integer where n is greater than or equal to 1. So again, remember that n is the term. So in a sequence, we wouldn't have a 0th term. We'd have a first term, a second term, a third term. The other thing to note is that these sequences can also be found by subtracting the same number, but you don't want to think subtraction, you want to think addition. So if the numbers are getting smaller, they're not subtracting, they're adding a negative. That means it is negative. Okay, so in A, what would the first term be, Shanna?
4.
And what is D, Sydney?
For which one?
On A?
5.
And what would A sub 5 be, Jenna?
1, 2. Wait, isn't a sub 5 would just be 24 then? Would you stop?
In B, Sydney, what's A sub 1?
34.
What's D, Jenna? Careful on this one.
So it's not 27?
27 would be A sub 2, but I want to know D, the common difference.
Oh, okay. I definitely have this.
Okay.
Oh, 7. Oh, man.
The numbers are getting smaller, so it's
-7.
-7. And you can find D anytime by taking any term in the sequence. So I could take 6 and subtract the term before it. So 6 minus 13 is a -7. Or 13 minus 20 is a -7. So you will, to find the common difference, you'll take any term and subtract the preceding term. That way the sign will be correct. So Shanna, what would be D for C?
It'd be adding a half.
Yep. So D would be 1/2. So anytime the numbers are getting larger in arithmetic sequence, D is positive. Anytime the numbers are getting smaller, D is going to be negative. Okay, so here they're just showing you for those 4 was the first term, the common difference was 5. In B, the first term is 34, the common difference is a -7. In C, it's a half, not a third. All right, here's the formula you need to know. To find the nth term in an arithmetic sequence, and you'll use this a lot in this assignment, to find the nth term, that is equal to the first plus n minus 1 times d. And so I just want to look at and see and explain that formula just a little bit, that hopefully it'll help you remember it. And it's going to, we'll be talking more about this a little bit later. So say we have the sequence 5, 8, 11, 13. Okay, so what would be D for this arithmetic sequence?
3.
These 3.
Yep. So if I wanted to know a sub 5 or the 5th term, I know the first 4, I could just add 3 to get 17. I'm going to show you this formula because if they wanted the 100th term, we'd want to use the formula. But for my purposes here, I want just some small numbers. So I had to add 3 to 5, I had to add 3 to 8, I had to add 3 to 11, and I have to add 3 to 14. So I've added 4 3s. We're looking for a sub 5 or n is 5. So the n minus 1 here just tells me how many times you're adding the common difference, which is 3. It just turns out that it's always 1 less than n because we start with a number. So in this formula, the n minus 1 just means how many times we're adding the common difference of d. We'll use this formula quite a bit in this lesson, so you'll get to know it well.
Is it a coincidence that the a sub 1 term and the n term was the same?
Yes, that is a coincidence. So I could have even put 17, and if I wanted a sub 6, that means this is still 5, but this would be 6. The common difference is 3. So this time we'd have 5 or 6 minus 1, which is 5 times 3 is 15, which would give us 20. But see, this time we added 3 5 times. This will always be n minus 1.
Okay.
So if we want to find the 14th term of the arithmetic sequence 4, 7, 10, and 13, to find this, you need to know 3 things. You need to know a sub 1, which we can easily see as 4. We need to know n, and n will always be the term they're looking for. So in this case, n is 14. So we're going to have down here 4 is the first term, n is 14. The common difference, they're adding 3 each time. Now be kind of careful here. The parentheses are required. So we're going to have to subtract 1, take it times 3, and then add 4, and we get 43. So pretty easy formula to use. Just kind of be careful of the order of operations. Anybody have any questions on that one?
Yeah, can you like repeat all that?
Sure. To find the 14th term, when they say find the 14th term, they're telling you n is 14.
Right.
You have to know the first term, which you can easily see is 4 in this example. Not in all of them, but in this one. And we need to know D. And D, there you can find D by taking any term and subtracting the preceding term. So 10 minus 7 is 3. So just plugging those numbers in, we put in 4 for the first term. We put in 14 for N and 3 for D. Just be careful of the order of operations. These parentheses are required. So 14 minus 1 is 13, times 3 is 39, plus 4 is 43. Okay on that?
Yep.
All right. Now in this problem, it tells us the third term of an arithmetic sequence is 8, and the 16th term is 47. Find A sub 1 and D and construct the sequence. So A sub 3 is 8, A sub 16 is 47, and so we need to find a couple of things there. We know those two terms. We don't know the first term. We're looking for that. It says we have to add D 13 times to get from 8 to 47. Why would that be the case?
Because
Because there's 13 terms in between A sub 3 and A sub 16.
Yeah. Because 16, A sub 16, A sub 3, you subtract the terms. So in that case, we have to, they're not telling us N in that case. They're telling us that's going to help us find D. So they didn't really point this out very good, but they're plugging this into the formula. They started with the 8th term. They added D 13 times to get 47. That's going to help us find D. And sometimes a picture of this is helpful. Let me see if I can. Because to me, that's kind of confusing where all those numbers came from. And I'm just going to. Huh?
My brother, I'm sorry.
4, 5, 6, 7, 8. So the third term is 8. 9, 10, 11, 12, 13, 14, 15, 16. And the 16th term was 47. Okay, so this kind of is what our sequence is looking like. And what they're saying, they had to add plus D here, plus D, plus D. So I'm really just counting the spaces in between here. And you would not work this problem this way.
Yeah, it'd take a long time.
Yeah. But 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 is, that's where they got the 13D. So 8, this term, plus 13D has to equal 47. Does a picture help you understand where they got the 13 from?
Yeah.
Yeah. So this was A sub 3, this was A sub 16. So we just took 16 minus 3. So then we just solved this equation to get D equals 3. All right, so now I'm going to use my formula, and it doesn't matter if you use this number or this number. I'm going to work it both ways to show you. I know that 8 is A sub 3, and that has to be the first term plus n minus 1 times d. Well, if 8 is the third term, that means n is 3. It's a coincidence that these two are the same. So 8 would equal a sub 1 plus 6. So a sub 1 would have to equal 2. Now, you can put this in up here to see if that works. We said we're adding 3, so 2 plus 3 is 5. 5 plus 3 does give us 8. So that works with the first 3. I could have chosen to use 47. And I'm using this formula. Okay, so the 16th term is 47. The first term I still don't know if I hadn't have done this. N for 47 would be 16. So we would have 47 equals a sub 1. 15 times 3 is 45. Subtract that from both sides. We still get a sub 1 equals 2. So it doesn't matter if you would have chosen this given point or this given point to plug into this formula, but you had to come up with D first. Does that example make sense?
Mm-hmm.
All right.
Stop.
Okay, the formula for finding the sum of the first n terms of an arithmetic sequences is given by S sub n. Remember, we talked about in 8.1 that when we see a in a subscript, that means a particular term of a sequence. S sub n means the sum of the first n terms. Now, I'm going to switch back and tell you a story. I don't know how true this is. I choose to believe it's true. There was a mathematician who was named Cardano, and he was a very bright young student, but he tended to kind of cause some problems in class. Sound like anyone you guys know? I mean, I'm not saying there's anyone specific, but you probably know someone like that who's pretty smart, so they use their time to cause problems. So the teacher, in order to punish him, said, okay, I want you to go and add up all the numbers from 1 to 100. And she thought this would keep him busy for a while. And so he looked at this problem as this. So here's his job, was to add up all those numbers. Well, he noticed that if you took the first and the last term and added them together, you got 101. If you take the second and the second to last, you still get 101. And if you take 3, the third number, plus the third one from the last, you still get 101. So he said, oh, I think if I pair up all the numbers, I'm going to get 101 every time. And since there's 100 numbers, that means there's 50 pairs. So in the formula, the n divided by 2 is telling you how many pairs of these numbers you have. And you just have to take the first plus the last. And so he ended up saying, oh, well, I just have to take 50 times 101. I think that gives you 50/50. And so it didn't take him long at all to add up the numbers from 1 to 100. So I tell that story, like I said, I'm not sure if it's true or not, but it maybe will help you remember this formula where the sum of n terms is equal to half the terms times the sum of the first and the last. Okay, let's see how we can use this. It's the same one as Cardano's. So we're going to have 100 over 2. That means there's 50 pairs of numbers, and the sum of any of the pairs is 101, so we get 5,050. Okay, so Kendall accepts a job starting with an hourly wage of $14.25 and is promised a raise of 15 cents per hour every 2 months for 5 years. At the end of 5 years, what will Kendall's hourly wage be? So it helps you to write it as a sequence first. So he begins at $14.25. And after 2 months, he gets 15 cents more, which is $14.40. And after 4 months, he gets $14.55. So are we looking at a sequence or a series here? A sequence just means a list of numbers where the same thing's added each time. A series means we're adding them all up. What are your thoughts?
Sequence.
And I'd say it's a series.
Okay, so you're wanting to add all these numbers up to get to his final wage.
Oh. Duh.
That would be nice.
It took a bit for that to register.
That's okay, but always ask yourself, are we just, if you were trying to decide whether it's a sequence or a series, are we adding the same thing just to generate the next number, or do we need to know the sum of these? And you'll have application questions that involve both types. It seems like in the homework there were a lot with saving X amount of money, so on and so forth. It is arithmetic because they're adding 15 cents each time. Now, we're trying to find how much at the end of 5 years. Well, N would have to be the total number of raises, right? So how many times would he get a raise from now and at the end of 5 years?
Every 2 months.
Which is how many times a year?
6 times a year.
So that would be how many times in 30 years, or in 5 years?
30.
Right. So each year there's 6 raises, and 5 years, so 30. There'll be 31 terms because we have to include the first term. So after 2
The what
months,
term?
excuse me?
The what term? The first term you said?
Right, we have to include the first term. So there are 30 raises. So we have the first term, and after the first raise, we're at the second term. So it's one more. The original wage plus the 30 increases would be 31 terms. So we want to find the 31st term of 14.25 plus 31 minus 1 times 0.15. There's that formula that you'll use over and over, which gives us 1875. So at the end of 5 years, he should be making 1875. Are we okay with how come that's 31 and not 30? Anyone?
Yes.
Okay. I can go back. Sometimes it's helpful to kind of draw a picture, but that's kind of our n-1 right there. All right, so pretty short unit. You'll use that one formula over and over, and sometimes when they're looking for the series of the SMN, the sum of a series, it will not give you A sub n, and you'll actually have to use the A sub n formula first to find A sub n, so you can use the S sub n formula. So write both those formulas down. And if you don't have enough information for one, sometimes you can use the other to help you find it. Also, there are some questions involving sigma notation again, and I'm not sure that all of you were here during that. Does anyone have questions on the sigma notation? Let's just go over one for a minute here. Just because this can be a bit confusing, and I do want to make a point about this. Okay, so we're going to look at this notation here. And what would be the first term?
Four.
Close. Notice that this is a 3 at the end of 1.
Would be 12, wouldn't it?
Uh-huh. And the second term?
$15.
So we go from 3 to 4. So 4 times 4 is
Oh, 16.
Oops.
Yeah. putting in 5, we get
20.
putting in 6, we get
24.
putting in 7, we get
28.
putting in 8, we get 32. I'm going to stop there. How do I know I have to stop at that point?
Because it's the 8th.
Because it's the 8th. It says after you put in 8, you're done. So the first term you can always find by substituting the bottom number into this expression. The nth term you can always get by putting the top number in this expression. And then n is always the top minus the bottom, add 1 back. So n is 6. 1, 2, 3, 4, 5, 6. And we kind of talked about this in 8.1 in the sigma notation. If this wasn't a 1 down here, you have to top minus bottom, you have to add 1 back always because you're subtracting off one of the numbers. So now we could use our formula where we have 6 over 2, 12 plus 32. So 3 times 44, which would be 132, I think. Of course, in this one, we could just add all those up. But some of those will be a lot bigger, and some involve fractions, some in decimals. So go ahead and get started on those, and I'll be around here. I'm going to see if Gideon has trig questions. But otherwise, I'll be around if you want to work on these, and I'll be available for questions.
I have one question from the assignment yesterday.
All righty. Do I need to look at it or?
I don't think so.
Okay.
I know it's so easy, but I did it like 3 times and I got the same answer every time, and I don't know what I was doing wrong.
Okay.
And I believe it's one of those sigma notation ones.
Okay.
Yeah, so it's 5 on top, and then k equals 1. And the formula or whatever is 1 over 2k.
Okay. So putting in 1, what do we have?
You'd have 1/2.
Mm-hmm. Putting in 2, we would have
1/4.
putting in 3, we would have
1/6.
4
1/8.
and 5.
1/10.
Now we could get a common denominator. I think I just used my calculator to add all these up. Oops, 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 oops. Gotta pay attention to what you're doing.
Mm-hmm.
not you, me, I was. And I'm just gonna do a math, enter. Oops. Were you getting 137 over 120?
No. I just did it in the calculator, like I did, just put it all in there, like with the multiplying and everything, and I added them as I went, and I kept getting 5.
Okay, so tell me what you put in the calculator first.
So I did parentheses, and then I did 1 divided by 2 times 1.
Did you use parentheses on the bottom?
Yes.
Okay. And then you close, so it looked like that?
Yep.
Okay.
Then I
Plus-
might have pressed enter.
Oh, okay.
And then I did plus. And same thing except with 2.
And then you'd press enter again?
Yep. And see, that gets you 0.75, not 0.25. Oh, wait. They were adding it.
Yeah.
Never mind.
That's okay, because if we would have added our first 2, we would have gotten that. So
Right.
I just thought maybe you forgot these set of parentheses around what you're multiplying on bottom.
I didn't. I made sure to do them.
Oops.
I'm going to be.
Divide.
That's
here.
irritating.
Do what?
You've already got more than what I had. I don't know what.
Yeah. My suggestion, because of the parentheses in the order of operations, write out your sum and then put it in your calculator. Because most of them, they won't have very complicated formulas here.
Right.
Yeah, you may have done something like I did, like accidentally get a plus sign in there instead of a divided. Because I look at that and the division looks like a plus a lot of times.
Okay. Okay.
Okay. Any other questions?